Okay, for our optimization summary, we're going to start with a fixed perimeter, and it's going to be a rectangular area that we want to maximize. So this happens when the length equals the width. In the scenario when you have a fixed perimeter with a enclosed area only on 3 sides, and we want to maximize that area, then the length will be equal to 2 times the width. And I'll show an example of both of those. So for this for this situation, we will have a square shape. All the sides are equal because the length equals the width. And for the fixed perimeter and an area enclosed only on 3 sides, imagine you had like the wall of a house and then 3 pieces of fence. Well, the length, the longer side, will be equal to twice the width. So if this is the width, then this will be 2W. So twice that number. Let's try an example. So if we want to sketch an example of a rectangle with an area, a maximum area and a perimeter of 24, we know the shape, if we're going to maximize it, will be a square. So this perimeter of 24 meters, we want to evenly divide it amongst all the sides. Well, a square has 4 sides, so we're going to do 24 divided by 4, and that gives us 6 meters each side. Okay, and that's the first question. The second question asks about the maximum area. So now we think about our area formula. Area equals length times width. And in this case, it's 6 times 6, because the length and the width are the same. So the maximum area is 36 meters squared. If we were able to create this maximum area, but with, once again, a rectangle where the sides, where there's only 3 sides, but still a perimeter of 24, we know that this length will be the width, and this longer length will be 2 times the width. And these two will be the same length. So let's see if we can figure this out. We know that the perimeter, which is 24, will be equal to all of these sides added up. So we have width plus 2 width. Width plus width plus 2 width. Well, that's a total of 4W, or 4 width, equals 24. And we can easily divide, like we've been doing to isolate. And we get that the width is also 6. So same answer as before, except now the length is twice that number. So if I were to label it, then this value is 6 meters. This value is 6 meters. But this value is 2 times 6, so that would be 12 meters. And the area then of this shape, it's going to be length times width again, same formula. Area equals length times width. Substitute, length is 12 times the width is 6. That's an area of 72 meters squared. Much larger, in fact double the size, just by enclosing on 3 sides instead of 4. Alright, let's move on to the next example. If you have a fixed area, and this time we want to minimize the perimeter, once again the optimal shape will be a square, so the length equals the width. You get that square shape. All sides are equal to each other, so you have a square. And in this example, we just have to carefully use the information. We now will have been given the area because the area is fixed. So this shape that we're looking at has to be a square. We want to minimize the perimeter. Well, you don't divide by 4 because we know that area equals length times width, or in this case, the side length squared, because it'll be the same number twice. So we have 49 as our area. And if you remember from Pythagorean theorem type questions, in order to get rid of the squared, the opposite is square root. So instead of dividing by 4 in this case, we want to square root 49, and we get 7. So in the picture, each side will be 7 meters. Now, what is the minimum perimeter? Well, perimeter is just adding up all 4 sides, so 7 plus 7 plus 7 plus 7, or you might just want to say 7 times 4, because there's 4 of them, so that equals 28 meters, not meters squared, because now we're dealing with perimeter. Okay, when we move on to 3D shapes, you can have a fixed surface area, and we might want to maximize the amount of space inside the shape. So maximize the volume. And once again, the length or width of the square base, The ideal shape is always when it's square shaped, so we need to create a cube where the length, the width, and the height are all equal to each other. So we get a cube. So this is the same as this, is the same as this, all 3 dimensions. In this example, we need to think of the equations for each of these calculations. So surface area for a cube will be 6 times the area of one side, and each side can be written as s. So 6 times s squared, and that will give us that shape. So we want it to be a cube, remember, and we're just basically naming each side s. So s, 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 and s. Okay, so each of these will be s times 6, and we get surface area. Now we know the surface area has been given in the question is 54, so we have 54 equals 6s squared. We want to find the length, or find out what s is, so we need to get rid of the 6. So we have s squared equals 9, but once again that's still not the actual side length. We have to take the square root of 9. We get s equals 3. So we can go back to our image here, and in the diagram, instead of s now, you can write 3 meters. All of these dimensions are 3 meters. That's the first part of the question. Sketch the square-based prism with the maximum volume. If we want to know the volume, we have to think of the calculation or the formula for volume. It's length times width times height, and in this case it'll be 3 times 3 times 3, which is 27, and the units for volume are meters cubed. Okay, continuing with this square-based prism, if we want to minimize the minimize the surface area for a fixed volume, we still want to create a cube, so the length or width of the base or the height, they're all going to be the same value, because we have a cube, 1, 2, 3, all the same dimensions, cube. In this example, once again, start with the formula. So if we have the volume, we're going to use the volume formula, which is length with height. But because we're dealing with a cube, all those numbers are the same. So we often just pick a letter S to represent all of them. So this is S, this is S, this is S. So S times S times S is S cubed. Replacing the numbers, we have 64 equals S cubed. Now to undo a cube, you can't use the square root, because that only undoes when we have, that's only the opposite of squaring. So we have to find the cube root button on our calculator. It has a 3 and a root sign. So the cube root of 64, and that'll give us S by itself. And S equals 4 meters. So in the diagram, if you'd like, once again, it says to show a labeled diagram, so we're going to make this value S 4 meters. So all of these dimensions are 4 meters. The second part of the question asks for surface area. Well, we need the surface area of a cube, which is 6, like we did before, times each side squared. So 6 times 4 times 4 times 4 squared. So 6 times 16 equals 96 meters squared. Okay, and that's our last cube question. Now we have a cylinder. In order to maximize the volume of the cylinder, so think of like a pop can, if they wanted to fit the most amount of juice inside this pop can, or the pop, I guess, inside the pop can, the ideal situation would to actually make the height the same as the diameter. So in that case, the shape would look a little bit different. It'd be a short, stumpy tube. You'd have this dimension across, that's the diameter, the same as the height. And that's the height over here. So this dimension would be the same as the one going across. But most of the formulas don't have diameter. Instead, they have radius, which is labeled from the middle to the end. So this radius dimension is related to the height in that the height is exactly double the radius. So the height is 2 times the radius, so that the diameter and the height will be the same. And that's the optimal shape. Now, it might not be optimal to hold, so we don't always see pop cans that look like that, but that would be the most volume. In order to solve a problem like this, we have to start with the surface area for a cylinder, which is a bit trickier. That formula involves 2 pi r squared to represent the circles, the top and the bottom, plus 2 pi r h to represent the lateral surface that goes around the can. But in our situation, we said that the height will always be equal to twice the radius. That's how we optimize. So whatever the height is, can't make it too tall, because we want it to be exactly, so if this is r, well then this height has to be 2r. So in our formula, if we replace everything we know surface area is 40, we know 2 pi, those are just numbers. We don't know r yet, but we're going to try to find it. And at the end here, instead of putting this h, I'm going to replace it with 2r, because that's what the height is equal to. So this involves some substitution and some simplifying and collecting like terms. So if we look at this expression, this polynomial, it says 2 pi r times 2r. Well, 2 times 2, they're numbers. We can multiply those. That's 4. Pi. And then r times r is r squared. So when I read this expression, I have 2 pi r squared plus 4 pi r squared. Well, in total, that's 6 pi r squared. And that equals 40. Now the goal here is to isolate r, and that's the only variable. So I'm going to get rid of 6 pi by dividing it on both sides. That's just a number. It's 6 times 3.14. And on this side that'll be gone, so I'll just have r squared. And here I will have approximately 2.12, and you can keep the entire answer on your calculator screen. Just make sure that your next step is to take the square root, because we want r by itself. So r is 1.5 meters. Okay, and if I take a look at the shape and I want to label it, well, if r is 1.5 and the height is 2r, so I could replace these numbers here. Instead of an r up at the top, I can put 1.5 as my radius. And instead of 2r on the side here, that means I have a height of 3 meters. So this distance here is 3, and the radius here is 1.5. So when we use our volume formula then, the second part of the question, maximum volume, remember for a cylinder the volume is pi r squared times the height. So we're going to use our numbers. Pi, r is 1.5 squared, times the height, and the height is 3 meters. When I multiply this out, you can do this in one step on your calculator. Remember to put the exponent. You will get 21.2 meters cubed. And I'm just rounding to one decimal place for all my answers. Okay, and the last question involves still a cylinder, but this time we want to minimize the surface area for a given volume. Still the same shape. We want to get 2 times the radius. So we want the diameter to be the same as the height, which means that if this is r, then the height is 2r. And for our example, we start with what we have. We have volume, so we're going to use that formula. Pi r squared h. We replace the v with 100. We know that our height is equal to 2r, so we're going to replace that as well. Pi r squared times 2r. We're going to try and combine any like terms. So we have an r squared times an r. Remember, there's an exponent 1. So in total, you have r3, and you still have the number 2 pi. So 2 pi is our coefficient. R3 equals 100. You always get rid of coefficients by dividing them out. So 2 pi is a number on both sides. Get rid of that. And what you're left with is that r cubed is equal to about 15.9. And remember, like what we did in the other volume question, you always need to undo the root by finding the correct value. So we need to get the third root of 15.9. So find that button on your calculator. And the third root of 15.9 is approximately 2.5 meters. Now, next question refers to surface area. So here's our shape. Let's draw it out. If the radius here, radius is 2.5 meters, the height is double that. So 2 times 2.5 is 5 meters. So there's our picture. We are going to use the surface area formula, and surface area formula looks like this. Surface area equals 2 pi r squared plus 2 pi r h. And replace all the numbers. So 2 pi 2.5 squared plus 2 pi 2.5 times 5. Sorry, running out of space here. I'll do that better. Okay, and then you can do all of that in one step on your calculator as well, or if you're doing it in parts, remember to use BEDMAS, exponents first, then multiplication, then addition, for a grand total of 117.75 meters squared for surface area. Okay, so approximately, we've been doing everything else to one decimal place, that would be 117.8 square meters. And that's it.